Hello everyone, hope you're having an amazing day. Welcome back to Apply AI in Sport Management. I'm Dr. Q, and I'm super excited today to chat with you about an interesting application of large language models, or LLMs, something transforming how we handle information. Specifically, I will be sharing how we can use a powerful LLM like GPT-4o to automatically and systematically filter and organize data for your sport management research, right from your web browser using Google Colab. Now, I know we have folks with all sorts of backgrounds watching. Some might be new to AI, some might be new to coding, but don't worry. I will keep this demonstration super accessible and super conversational just like always, while still giving you practical tools you can use. So without further ado, let's dive in. So what exactly are large language models? So imagine you have a super smart research assistant. This assistant has read billions of pages of text, books, articles, websites, you name it. Because it has read so much, it's incredibly good at understanding language, recognizing patterns, summarizing information, and even following complex instructions. So that's what an LLM like GPT-4 is. So I'm using OpenAI's models example. So GPT-4o is more accurately a large multi-model model. I know it's mouthful. Trained on vast amounts of image and text data. It doesn't understand like a human, but it's brilliant at predicting what words should come next, which allows it to generate text, answer questions, and importantly for us today, analyzing and categorize information based on instructions we give it. So why this is a game changer for sport management research or social science research in general. Think about all the text data we deal with, then comments, social media posts, news articles, individual scripts, and even scouting reports. Large language models can help us sift through huge volumes of this text quickly, finding exactly what we need. It's like having a super assistant instantly read and sort thousands of documents for you. Alrighty, let's make it real. We're going to walk you through a practical example. Philip and I are currently working on an exciting project involving the Tomorrow Golf League, or TGL, an innovative golf league that combines golf and advanced technology. We have gathered extensive YouTube data, video titles, descriptions, authors, and other pertinent metadata using keywords like TMRW Golf League and TGL. However, not every video containing these keywords really relates to our league. For instance, some might mention TGL in completely unrelated contexts, such as gaming tournaments or other brands or events using similar acronyms. Therefore, we need to efficiently filter the collected data to accurately pinpoint only those videos genuinely relevant to our specific context. This is where LLMs come in. We can write a short prompt to ask GPT-4o to review relevant information for each video and give us a relevant score for decision making. So we'll be using Google Colab to run this application. Google Colab is something we discussed and utilized in our first video. And I think it's a fantastic free tool that allows you to run code directly in your web browser, and there's no complex setup is required. And you can directly download or just save a copy of this codebook directly um, from our GitHub repository. And I have already included that link to our repository in the video description. So first thing first, we need to set up our tools ready. So what you need to do is basically run a quick setup cell right here. Click the play button. And this is basically installs all the necessary libraries, like tools from a toolbox for handling data, like pandas, data sets, interacting with OpenAI, and showing progress, which is TicketDM, because we always want to be informed, right? So we always securely load all the functions, all the specific functions that be utilized in our workflow right here by clicking the second setup cell. What it do is basically help us securely load all the functions as needed in this workflow, and we load our OpenAI API key, and which allow us to access GPT-4o. Next, okay, so next we're gonna load our data. In this case, we're actually pulling a sample data set directly from Hugging Face, just like what we did in our first video. And by the way, Hugging Face is a great platform for AI resources. Feel free to explore it. I believe I've already demonstrated some of its amazing resources available on the platform. But this data set we are pulling right here, we're going to click the cell. This data set has YouTube video titles, descriptions, and authors, and other, as you can see, likes, comments, other metadata, which I believe will only use 3 of the variables here, columns here, to help us to do the organization and the filtering task. And we're going to click the next cell. It's give us a good overview of what the data set actually looks like. And next is actually our core part. This is, it looks a little bit overwhelming, but I'm gonna tell you like what exactly it does in this process in our workflow. So this is the core part right here. This is the system prompt section where we tell GPT-4o what to do. Just like I said before, the crucial part within this function is the message list. Right here, we have the system prompt. It's like giving GPT-4o its job description. You are an expert classifier. Your job is to read the text and tell how related it is to TGL. We gave a brief definition of what TGL is, and using the specific 1 to 5 rating scale. If the author is at TGL, it gives automatically 5, and give me an answer only in a clean JSON format. The filter rating with its specific number of rating. The user message right here, we are actually here. This is provide action data for specific video and combine the title and the description for GPT-4o to make better informed decisions. And like I said, we are actually forcing JSON output. This forces GPT-4o to give us answer in a neat, predictable format that our code can easily parse out, understand, rather than a chatty sentence. And this is extremely helpful. And we also set the temperature of the response is 0. This will give us consistent answers without a lot of variability. We're going to talk about more in the follow-up videos. All right, so now we just need to click the cell and run the function. So what it does right here is actually the loop will go through each row for each video in our table, in our data set. It checks that special rule. If the author is TGL, it automatically assigns a 5. Otherwise, it combines the title and description and sends it to our classifier, GPT-4o, to get the rating from the model. And TQDM right here is actually shows a nice progress bar and we can know where we're at this moment. And finally, we can add this readings back into our data set, into our table and display the results sorted so we can easily see the most relevant videos first. So, and just like that, instead of hours of manually reading, I know we just show a small sample, a small case study for this classifier, but you can tell this is approach that is scalable and that can be replicated in other contexts if you have similar tasks in nature. So we have used GPT-4o to automatically filter and rate our video data in, in just a few seconds. Imagine applying this to analyzing fans' feedback, sorting sponsorship mentions in news articles, or um, categorizing player information, performance metrics. I'm just thinking out loud. The possibilities are huge. Okay, let's quickly wrap up our workflow of this demonstration. So first, I would say models like GPT-4o are really powerful AI tools, trained on vast amounts of text and images, and we can use them as smart assistants to analyze data at scale, and that's very important. Um, and next, another important takeaway is actually by writing clear instructions, the system prompt, as we demonstrated today, and using platforms like Google Colab and OpenAI API, even complex filtering tasks become manageable at scale and accessible to folks who really don't have much experience in terms of coding and AI. And the next takeaway is actually structuring output, okay? And we structure output such as requests in JSON, makes AI responses easy to use programmatically. It helps us to really easily parse out the output in a consistent manner. And also by incorporating parameters like temperature zero ensures the responses are consistent. And lastly, human evaluation remains the core, remains essential to this workflow. So we need to include, as we did in our system prompt, included a manual classification option in our progress in case automated methods do not perform adequately. And in addition, it's important, although we did not do that, incorporating performance metrics such as precision, accuracy, and F1 score is critical to quantitatively assessing and improving our work. Think about the data you work with. Could a large language model, could an LLM help you make sense of it faster? Try adapting the prompt in the code we share for your own needs. Experiment. Experiment is all you need. That's the best way to learn, right? So if you find this helpful, give us a thumb up and subscribe for more Apply AI sport management content. And definitely drop your questions, ideas in the comments, or just leave a message in the GitHub repo. I'm happy to assist and happy to help. So thanks for joining me today. Thank you for watching. Hope you're having an amazing rest of your day, and I'll see you in the next video. Take care.